Hello students, so in this lecture we will be talking about wave motion and we will discuss about Huygens principle. Now we know that when we say wave, the first thing that comes to our mind is shaped like this, ups and lows. Now technically these ups are called crest and the lows are called trough. And this periodic variation is actually mathematically it's called sinusoidal. Means represented by a sine wave. So we can write YRT is equal to Y0 sine 2 pi by lambda by lambda r minus Et, where this is the wave displacement, this is the wave displacement, it's a wave amplitude, R is the position along the traveling of the wave, this R or this R, and V is the velocity. Now this is also called the phase angle. Let's denote it by phi. So phi is now 2 pi by lambda r minus Vt. Now this phi is same for any point on the given wavefront. So we can say if this is the wave, so we can say that this value of phi is same anywhere. That is in successive wavefronts. So if we say that for successive wavefronts, by wavefronts we mean a particular value of phi. So let's say for the first case it is pi by 2, and for the next case the value of pi is pi by 2 plus 2 pi, and then pi by 2 plus 4 pi, and so it will all the wavefronts will be 2 pi radians apart. And sine phi for all these wavefronts should be equal to 1. And this is equal to 1, then y0 automatically y0 is the maximum possible displacement. Such wavefronts are crests, so this is the maximum possible displacement. That means we are talking about this position, so it automatically can call it a crest, as we have previously mentioned. However, if we take the values of phi to be 3 pi by 2 or 3 pi by 2 plus 2 pi or 3 pi by 2 plus 4 pi, then sine phi will be equal to -1, and so in the wave this yrt will be equal to -y0, so it will be the lowest point. So this will be nothing but it's the drop. So maximum negative displacement possible. Now coming to light waves. Light is an electromagnetic wave, so there are electric and magnetic fields E and B. They vary between positive and negative maximum, and interaction of light waves can also occur. So if they interact, then the principle of superposition is applied. So there are two postulates in the principle of superposition. The first postulate says that when two or more waves move simultaneously through a region of space, each wave proceeds independently as if the other wave were not present. So in short, we can say that two waves travel simultaneously, and they are independent of each other. One is not existing for the other. And the second postulate says that the resulting wave displacement at any point of time is the vector sum of the displacements of the individual waves. That means if there are two waves interacting, so the resultant displacement will be sum of displacement of the individual waves. So let us try to understand it graphically. Say you have a wave like this. Let's erase this one. Say one wave is traveling like this, and another wave is really traveling like this. So the resultant wave, so this stands for say y1 and this stands for y2. The resultant phase will have a shape like this. Initially it will be okay, so this is y resultant and it is equal to y1 plus y2. Okay. Now coming to Huygens principle, or we can call it Eigens Wavelets. So it says that every point on a known wavefront in a given medium can be treated as a point of source of secondary wavelets. So every point on a known wave front in a given medium can be treated as the source of secondary wavelets, which spread out in all directions with the wave speed, which is spread out at all directions with the speed characteristic of the medium, with speed characteristic of the medium. So schematically we can see that, say you have a plane wave, for example. So each point, so it's P1, P2, P3 and P4, each of these points act as a source of secondary wavelet. So create wavelet like this, so that you have another, so this becomes the envelope, and this is the direction of propagation. And it can also happen for spherical wavefronts, like this initial spherical wavefront. So you have points P1, say P2 and say P3. So each of them will again be the source of secondary wavelets, so like this. So again this becomes the wavefront. These are the secondary wavelets. This one and this one, and this is the envelope. A plane wave will have a plane polarized wave, a plane envelope. A plane wavefront will have a plane envelope. A circular wavefront will have a circular envelope. So this is again another postulate of the Huygens principle. It says that the developing wavefront at any subsequent time is the envelope of these advancing spherical wavelets.